I think the instructor who took the session, by mistake, it was not saved in their local system. So that's why we are unable to upload. But rest PDF for rest weeks, I think we have uploaded. Okay, all right. So we are live now. Let me share my screen and we will start. No, it's not like you will not get questions from week 3. Okay, so it doesn't mean you will not get questions. You will get questions from week 1 to week 4. Okay, can you see my screen?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So major concepts from week 3 and week 4 are, we will start with what is the expected value. I mean expectation of a random variable. Then second thing, we will see what is variance and standard deviation. And third thing, we will see what is covariance. There is some background noise. And fourth thing, after covariance, we will see what is the correlation coefficient. And then next part, we will see the important inequalities called Markov's inequality. Okay. After Markov inequality, we will see Chebyshev's inequality. And then we will move on for week 4. Okay. So in week 4, basically we will see what is the CDF for discrete. Then we will see CDF for continuous. Then what is the PDF. Okay. So before PDF, we will see what is the continuous random variable. Okay. Then from CDF of discrete, we will move on the continuous random variable. Then what is the PDF? PDF stands for probability density function. Okay. And then CDF and all. So we will, these are the major topics, okay, which we have to cover, okay, today's session. So let's start from the expected value of a random variable. Okay. So I think from stats 1, you are aware about what is the expectation and all. So what is the expected value? Anyone?
It is average of
It's the means.
mean.
Okay. Any other thought? Why we are moving to the expectation of a random variable?
Because it is the most
Sir,
probable thing to occur.
when we repeat the experiment multiple times, this value is the like kind of average value we get, or the expected thing. Like if I get an expected value of 3.5 from 10 outcomes, then I can say if we repeat 10 trials, then we can say that if we repeat that 100 times, we can get a value of 35, something like that.
Okay.
It is like most likely to
So
occur.
yeah. So suppose I'm saying X, I have a random variable, okay, and it, so far we will discuss about discrete random variable. So suppose this X is taking some value x1, x2 up to xn, okay, and let's say probability associated with each value is, let's say, p1, p2 up to pn. Okay. So suppose this is information about your random variable. Okay, means I'm saying I have this random variable as x, and the random variable x is taking these values x1, x2 up to xn, and probabilities associated with each value is, let's say, p1, p2, pn. So this is information. So what if I want to explain, or I want to give, or you can say I want to suppose. Very simple question. Suppose I ask you, explain your random variable in a single value. Okay. So anyway, this is the whole information about your random variable. What if I will ask, explain your random variable in a single value? So in those scenario, this expectation comes into the picture. Okay. If you will say expectation of x is, let's say, 2, then you will have some idea, right? Some central idea about your random variable. Yes or no?
Yes.
Okay. So let's start how to calculate this expectation of your random variable. So expectation of x is nothing but x1 into p1 respective probability plus x2 into p2 plus so on xn into pn. So in short, I can write summation of x belongs to tx, means tx is nothing but range of x into probability that x equal to x, or else I can write summation throughout the over the range of x into fx of x. Yes or no? Right?
Yes.
Okay. So this is the expectation. This is the way how you can calculate the expectation of a random variable. So for example, I will take very simple example. Then I will take. We will discuss the questions from this PDF. So suppose I'm saying my random variable x is such that it is taking value 1, 2, 3, and 4. Let's say for simplicity, for each values probability is same. Let's say 1 by 4, 1 by 4, and 1 by 4. So what will be the expected value of your random variable? And I mean, how you will calculate the expectation of x? So if you see the formula, what is the formula? X into basically x1 into p1, x2 into p2. So what I have to do? 1 into 1 by 4 plus 2 into 1 by 4 plus 3 into 1 by 4 plus 4 into 1 by 4. Correct? So 1 by 4 I can take common. It will be 1 plus 2 plus 3 plus 4. So which is nothing but 4, 3, 7, 2, 9, 10 divided by 4, which is 2.5. So this will be your answer. All right. Any doubt?
No, sir.
Okay.
No, sir.
So if this is okay, so similarly, what if you have been asked expectation of function of random variable? I means rather than I'm asking what is the expectation of x, suppose what if I will ask expectation of x square, expectation of 2x, expectation of 2x plus 3, anything, right? So how will you proceed? So suppose I'm saying I have random variable x1 up to, I mean, these are the values and this is the PMF, okay, for this random variable. So what if I each xi, okay? So we will see the example, do not worry. So how will you calculate expectation of y? So first of all, by the basic definition, what you will do? Summation of y into fy of y. Yes or no?
Yes.
Right? And this y is nothing but
Function
this will
of
be
x.
g of
Tuple.
x1, x2, your function of a random variable. And what about this part, fy of y?
PMF of that function.
PMF of that function. Okay, let's try to, okay. What if expectation of x square? How will you proceed? It will
Summation
be
of
summation
x.
of x square into probability
times
x
probability
equal to x.
Yes.
Yes or no? And this is what? This is nothing but function of x, right? You can say this is as a y. All right.
Yes.
Yes, sir.
Okay. Let's try to do one example. Suppose I'm saying x follows discrete uniform and take values are -1, 0, 1, for example. Okay. If this is the case, what will be the expectation of x? And since it's a discrete uniform, then what will be the probabilities for each value? It's 1 by 3, 1 by 3, and 1 by 3. Yes or no?
Yes.
So expectation of x is what?
0.
Summation of x into
0.
px. So basically it will be -1 into 1 by 3 plus 0 into 1 by 3 plus 1 into 1 by 3. So this will be 0 and this will get cancelled out. It's a 0. All right. Any doubt?
No.
Sir, that 2.5 value above in the above page. So this expected value 2.5 cannot occur directly in this given choices. 2.5 cannot directly occur, right?
Yes, yes. It's a long run average. Okay.
Yeah, long run average. Yes.
Correct. So if you are going to perform in your experiment, right? Let's say you are going to throw a die. Okay. Let's say some for long times, right? Long. Let's say some
1000.
Yes.
500 throw or 1000. So the average of the results for all the throws, right? That will be close to your expectation.
Close, yeah, most likely to be
Correct.
22.5.
Correct,
Okay.
correct. So that is the meaning.
Okay.
It doesn't say, it doesn't mean it will give you the exact value. Okay.
Yes, sir. Okay.
Just give me 1 minute. Let me
Prashant
connect
sir,
my
your
laptop.
battery.
Yeah.
Battery.
That's all. Yeah. Thank you. Okay. So suppose in this case, I'm saying, let's say y equal to gx means function of my random variable is, let's say for simplicity, let's say x plus 2. Okay. Then how will you proceed? Another way is I can apply the properties of expectation that we will see in a minute. But before that, let's try to do. So one way is, what will be this? So x is what? -1, 0 and 1, right? Then what will be y equal to x plus 2? It will be -1 plus 2, that is 1, 0 plus 2, 2, and 1 plus 2, that is 3, right? This is the possible values for y, right? What will be fy of y? 1 by 3, right? Probability will be the same.
Yes.
Correct?
Yes.
Now, what will be the expectation of y here?
I see.
So summation of y into probability of y equal to y, right? Basically 1 into 1 by 3 plus 2 into 1 by 3 plus 3 into 1 by 3. So 3 to 5, 6 by 3, which is 2. Yes or no?
Yes.
Right? Now, we will do the same question with different approach. How? Before that, let's try to see the...
Sir,
Yes.
so I have doubt in a similar type of question. Can you please discuss that question also?
Where, from where this question is?
Sir, I'll send it in chats.
Okay. Yeah,
And
okay, you
sir,
can
this
send.
above,
Hmm?
sorry, this above probability that you just did,
Hmm?
this is for 1 function. Like since f of y is 1
Correct,
1.
correct. It's for discrete. Yeah, that's discrete is 1 to 1, right?
No, but what for x square we would have to be careful. Like you see, -1 square and 1 square will be the same. So for
Hmm.
that we have to be careful, because then the PMF,
Then PMF will get changed.
it will be changed. But
Yeah,
for 1 1 it is always the same as
correct, correct.
x.
Or else, okay, okay. In that case, you can do like this. So suppose I'm asking, let's say y equal to x square,
Excuse me,
for
sir.
example. Yeah, 1 minute. Let me explain this part, right? I think. Okay.
Yes, sir.
Yeah. So suppose this is y equal to x square. Okay, I'm saying. So what will be the expectation of y? So what you can do, simply summation of x square, okay, into probabilities at each values of x. That's all. All right.
Also x is equal to -x.
No, sorry. X
X
equal to...
square into probability of x equals x, and also probability of x equal to -x.
All
No,
the
no, no.
values will be
One second.
considered here.
Here, all the values are already considered. Okay. In this case, what will be the? I mean, How will you proceed? So basically what you have to do, minus x square. So this is minus 1 square into 1 by 3 plus 0 square into 1 by 3 plus 1 square into 1 by 3. That's all. So it will be 1 into 1 by 3 plus 0 plus 1 into 1 by 3, which is 2 by 3 will be answer.
Oh,
Got
okay,
it?
okay. So we eventually we also
Correct,
considered.
correct. Okay.
Yes, yes.
So there are some properties related to expectation. Yeah, someone was asking some question. You can just keep that question with you. We will discuss in a minute. Okay. So properties are nothing but expectation of a constant is nothing but that constant only. Okay.
Sir,
Yes.
I was asking that only, that how we will came to know that we have to solve for this method or for this method.
Which method?
You have just done two methods, this old one and this
I
new
didn't
one.
discuss the second one, right? Let me discuss. Okay. So anyway, either way is a good one. I mean, you will get the correct answer. You can proceed with this also. You can proceed the next one also. That's not a problem. Actually, in the second approach, I'm just going to apply the properties of expectation. That's all. Okay. Both method is correct. Okay. Okay.
Sir, I'm unable to
You
attach
understood
that
this
image.
approach or not? This one.
It is understood.
Yeah. Then it's okay. Okay. So yeah, so expectation of a constant is nothing but the constant only. Over here, C is the constant. Okay. Second property says expectation of C plus X, where X is your random variable. So I can write this one as a expectation of C plus expectation of X. So this will be same as C plus expectation of X. This is same you can recall from starts one adding and subtracting a constant. Yes or no?
Yes.
And expectation of C times X, it will be C times expectation of X. Okay. We are not doing the derivation part. These all things you can keep in your mind. Okay. So derivation, it's very easy. You can cross check actually. And what if I have two random variables? So expectation of X plus Y, I can write this as expectation of X plus expectation of Y, irrespective of whether it's a dependent or independent. But this will affect in case of variance. We will see when we will discuss the variance part. Expectation of AX plus expectation of BY. This part I can write expectation of AX plus expectation of BY, right? And this part I can write as a expectation of A times plus, into expectation of X plus B times expectation of Y. Everyone is getting these two parts?
Yes, sir.
Yes,
Yes.
sir.
One more thing, expectation of X into Y, this will be same as expectation of X, expectation of Y, only if your X and Y are independent.
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 Only in this scenario, these two will be equal. We will see how. Okay. Now, if you come to this part, right, here I can apply the properties, right? We have expectation of Y as expectation of X plus, oh, sorry, plus 2, right? What I can write this as a expectation of X plus 2 or not. And we have expectation of X we calculated as a 0 plus 2, which is 2. So you can see from this approach also we got the same answer which we got here. Is this clear?
Yes, sir.
Okay. So far so good. Anyone? Is this fine, right? You are getting the idea?
Yes.
Yes, sir.
Okay. All. Yeah. So we will try to finish the concept first, then we will move on the questions. I have some collection of some 10 questions, including sub parts. There will be more than 10 questions. Okay. And we will see how what kind of questions we have already asked. Okay. Next part is
Excuse
variance.
me, out, sir.
Yes. Yes.
You said that okay, E of xy is equal to E of x into E of y only if they are independent.
Correct.
What if they are not independent?
You can't say these two are equal. I will come to that.
Okay, sure.
Whenever we will discuss the covariance part, it will be clear to you. Okay. All right. Okay, so next part is variance. So what variance tells us? Basically, variance tells us the variability in your data set, or you can say how much spreadness is there in your data set. So when variance comes into the picture, so let me take very simple example. Suppose I'm saying I have two data set. Data one, let's say I have these kind of observations, and in data set two, I have these observations. Okay, if you see, what is the average of this data set?
Three.
3. What is the average of this data set?
Three.
3.
Okay. So average is 3. Average are same for both data set, right? But can we say in reality both data set are equal
Yeah,
based
no.
on
No.
average only?
No.
No.
No, right? There are some spreadness, there are some variability in your data set, right? Yes or no?
Yes. Yes.
Yes, sir.
So you can also think like this. Suppose this is the data of some 5 students from college A and 5 students of college B of their packages. So just consider in this as a in 10 lakhs, means suppose this is 10 lakh, 20 lakh, 30 lakh, 40 lakh, 50 lakh. This is 30, 30, 30. So on an average, suppose average is 30 lakh package and here average is 30 lakh package. So it would be good you are making conclusion performance of the students in placement of both colleges is same.
No,
No.
sir.
No, right? Because of this, there is variability. So that's why variance comes into the picture. So what is the variance and how to calculate? Okay. So variance is nothing but we need to check the deviation of your x from their expected value. So this is mu. Mu is nothing but expectation of your random variable. Okay. So if you will expand this formula, right? That means if I will do x square plus mu square minus 2 times of x into mu. So this will give you expectation of x square plus expectation of mu square minus 2 mu expectation of x, right? 2 mu I took outside because
Yes,
mu
sir.
is the constant, right? Expectation of x square plus here it will be mu square minus 2 mu, and expectation of x is we know we have given as a mu. So now we got expectation of x square plus mu square minus 2 mu square, expectation of x square minus mu square, and this formula is very popular, expectation of x square, and mu we know what is this, expectation of x whole
X.
square, right? So this is one another form of variance of x. Okay. So this is helpful because suppose you have calculated expectation of x and then you have to calculate expectation of x square, and then you can find the variance of a random variable. This one is also correct. That's not a problem. Either way is correct, but most of the time I'm preferring this one. Just I don't know. I mean, it's handy for me, but yeah. So let's do one example. Then we will.
Sir,
Yeah.
one request. Can you show the above page where you write the expectation?
Which one?
Okay, this last six property I missed actually, so I just need
Okay.
to see. Okay, fine. Okay.
So let's say in this question, I've been, so suppose my question is what is the variance of x? Okay. Then what you have to do? Expectation of x square minus expectation of x whole square. Yes or no? And we have calculated expectation of x in the previous part as 0, right? Can you recall?
Yes.
Yeah.
Yes.
Yes.
So next thing is we have to calculate the expectation of x square. Expectation of x square means we have to do summation of x square into probability for each values of x. So it will be minus 1 square into 1 by 3 plus 0 square into 1 by 3 plus 1 square into 1 by 3. So it will be 1 by 3 plus 0 plus 1 by 3, which is nothing but 2 by 3. So if you will substitute the values here, so variance of x will be 2 by 3 minus 0, which is 2 by 3. Is this clear?
Yes.
Yes,
Yes,
sir.
sir.
Okay.
Yes. Yes, sir.
So if this is okay, so I'm hoping you are already aware about this standard deviation. Anyone, any thought? What is the use of standard deviation? So standard deviation of
To match the units.
correct. Okay, this is nothing but square root of your variance of x. So what, because of suppose my random variable x is age of some person. Okay, if this is age of person, so it will be in year, right? If you will calculate variance of x, it will be in year square. But if you will calculate standard deviation of x, it will come under in the original unit of your random variable. Okay, that's the key idea. All right.
Yes.
Yes, sir.
So next part is it's some properties related to variance. Okay, so variance of a constant is always 0. Okay, because of variance of x is what, expectation of x minus mu whole square, right? So variance of a constant will be what, expectation of c minus and expectation of that constant, so it will be 0 or not,
Yes, sir.
right? Second property is variance of a times of x is nothing but a square variance of x. So you can substitute the values, okay, in the formula only. So I'm just derive. I will derive only this formula. Rest you can approach. So what is the variance of x? Expectation of x square minus expectation of x whole square. This is the original formula of variance of x. Variance of a times x will be what? Expectation of a square x square or not, minus expectation of ax whole square. Yes or no?
Yes.
Yes, sir.
So next part will be variance of ax. So a square I can take common here, I mean outside this bracket, and here if you take a as a common, I mean a outside, then it will be a square expectation of x whole square. Yes or no? A square you can take common from here, it will be expectation of x square minus expectation of x whole square, and this is nothing but variance of x. So you can check variance of a times x is nothing but a square variance of x. Okay, if this is the case, so can you tell me what will be the standard deviation of ax?
A into standard
A
deviation of
times
x.
A into
Right,
standard deviation of
because
x.
square will be under square root, so it
Root.
will be a times, right? What about variance of x plus a?
Variance of x of
Variance of a
X.
x.
x, right? Because variance of a constant will be 0, right? Where standard deviation of x plus a,
same.
standard
E
deviation of
of
x,
x.
right? Now another property which I was giving, actually, so variance of x plus y in general, it is variance of x plus variance of y plus 2 times of covariance of x comma y. But if I'm saying, suppose if x and y are independent, okay, in that case I will say correlation between x comma y is 0.
0.
If this is the case, covariance will be x comma y 0. That's why variance of x plus variance of y. So variance of x plus y is equal to variance of x plus variance of y when if x and y are independent. Okay. While you can say, you can see in case of expectation, there was no any condition in case of addition of two random variables. Okay.
Yes.
And similarly, you can proceed for standard deviation of x plus y. I mean, suppose my question is what is the standard deviation of x plus y? If x and y are independent, then just calculate the square, I mean, square root of variance of x plus y, and you will get the final answer. All right.
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
So next major concept is called
So can you show
covariance.
that
Okay.
again?
So covariance, okay, covariance tells us linear association between x and y. Okay, so just keep in mind, covariance is always all about linear association between x and y. Okay. I will give you one statement, maybe that will give you some idea. So how this is defined? So covariance between x comma y, formula for this is nothing but expectation of x minus expectation of x into y minus expectation of y. If you will solve this, you will get expectation of x into y minus expectation of x into expectation of y. So this is the formula for covariance between two random variable x and y. So whenever you have been asked covariance between x and y, just proceed with this. I mean, calculate the x into y, and for this part, you have to calculate the you have to multiply with the joint probability, and expectation of x you know how to calculate, expectation of y you know how to calculate. One key thing you can observe here, what if I will ask covariance between x comma x? This will be
One.
expectation, no, not one.
Variance of x.
Zero.
Correct. Not zero. Do not say anything blindly, right? Just think. This will be expectation of x square, expectation of x whole square. That this will give you the variance of x. Okay. Fine.
Okay.
Right? No. Now one more thing. If I'm saying the key thing which I'm going to discuss, if x and y are independent. So if I'm saying x and y are independent, that means there will be no correlation. Any kind of relation will not be there, right? If x and y are independent, then I can say covariance between x comma y will be 0, because covariance tells us what? Linear association. If I'm saying x and y are independent, that means there will not be any association, right? If covariance this is 0, covariance between x comma y is 0, what I can say, expectation of x into y minus expectation of x into expectation of y will be 0. Yes or no? This is the formula of
Yes, sir.
covariance, right? If this
Yes,
is
sir.
0, can I say expectation of x into y? This will be same as expectation of x into expectation of y.
Yes, sir.
Now this is clear. I wrote in case of expectation this part,
Yes, sir.
right? So this is something you can keep in your mind. Another thing, you will give me the answer for this part. Okay. Suppose I'm saying if covariance between x comma y is 0, will this imply x and y are independent?
No.
No.
Why?
Yes.
No, because
Yes.
there will be some cases where we can get that expectation of x, like xy equal to expectation of x into y, but in that case that will not that will be not independent if we will check by like simple method.
Like there may be certain values because of which covariance turns out to be zero, but that
Correct.
must not always
So
be
one
there
thing,
in.
yeah, correct. Maybe you can relate now. So see, covariance tells us what? Linear association between x and y, right? Yes or no?
Yes.
Yes.
Yeah.
So if I'm saying covariance between x comma y is equal to 0, this means x and y are not linearly related.
Okay.
Okay. There might be another kind of relationship. For example, suppose I'm saying x is I have and y has been defined as a x square. In this case, it is also possible covariance between x comma y is 0, but we can't say x and y are independent because y and there is a one kind of quadratic relationship between x and y. All right. So if
Yes.
covariance is 0, you can't say x and y are independent. You can only say x and y are not linearly related, but there might be another kind of relationship. Is this clear?
Yes.
Okay.
Excuse me, sir.
Yes.
So could you please show that properties, last property? Actually, I missed that.
You want to take a screenshot?
No, sir. I just want to see something. I
No.
missed one term, so.
Now it's just fine.
Mm, So properties of variance, last part. Oh yeah, this one.
Clear? Any doubt?
Oh yes, sir. It's under root only. Yeah.
Okay. So next part is, can you tell me when covariance will be positive?
Sir, can you please explain the last one again? The relation.
This one?
Yes, sir. Yes.
Yeah. So here it's nothing but if you are saying covariance between x comma y is 0, then you can't say x and y are independent, right? You can only say x and y are not linearly related. Okay. There might be some kind of relationship, suppose x and y equal to x square, where covariance between x and y will be 0, but here you can say there is a quadratic relationship between x and y, right? But if I'm saying x and y are independent, then I will say covariance is 0. Okay, independence means there is not any kind of relationship between x and y. All right.
Yes, sir.
Okay, so let me draw a graph, then you will get the idea when covariance will be positive, negative, or something like that. So suppose this is for your x and suppose this is for your y. If this is the x, assume x bar is somewhat here and suppose y bar is somewhat there. Okay. Okay. You will tell me what will be x minus x bar here. It's positive or negative?
Negative.
Negative.
Hmm.
yi minus y bar here.
Positive.
Positive.
In this part, x minus x bar.
Both positive. Positive.
Positive.
yi minus y bar.
Positive.
Positive.
Positive. In this part, x y minus x bar.
Negative.
Negative.
Yi minus y bar.
Negative.
Negative.
And xi minus x bar. Positive. Yi minus y bar. Negative. Okay. What about product of these two?
Negative.
Negative.
Negative. Product of these
Positive.
positive. And the product of these two,
Positive.
product of these two,
Negative.
negative, right? So in covariance formula, you can see we have to see the product of x minus expectation of x, y minus expectation of y, right? So when you can say covariance is positive, I can say covariance is positive when, okay, you can relate with this part. So
Product
you
is
can
plus
say,
2.
sorry,
Both
I
are
mean, the product is
correct. So
positive.
when I'm
variation.
saying yes, this part, right? Product of these two is positive, right? Yes or no?
Yes.
You can relate. And when these two are positive, when x is
Both are
above
negative.
its mean, right? And y is above its mean. Yes or no? I mean
Yes.
this part. And or else you can say this is below its mean and below its mean. It means this part. Yes or no? In those two cases, you can say product is positive. Got it? And when covariance will be negative, value of covariance will be negative if x minus expectation of x into y minus expectation of y, means product of these two is negative. Okay. When it will be negative, you can check from here. When x is above its average, okay, and y is below its average, or x is below its average and y is above its average. Clear?
Sir,
Yes, sir.
Yes.
when calculating this x bar that you wrote, that will we can take normal average or always expectation.
Okay, this was just a graph. You have to go for the expectation. Okay, this is not normal average. We are talking about in terms of random variable. Just for simplicity, I took this one. Okay.
Okay, but while calculating in exam, if you there, then x bar must be substituted with expectation of x.
Uh, yes. So if I'm talking about random variable, go with the expectation of x. Okay. Because in stats on what we did, we have some data, we have been given some data set, right? Let's say data set of some 5 observation, and then ask calculate the sample covariance, for example. Okay, then you will do 1 upon n minus 1 summation of xi minus x bar yi minus, that is the separate. Here I'm talking about random variable. Okay, it can take any kind of value, anything, right? So, and since it's a random variable, I will go for the expectation of x. Okay, so go with this formula always. Whenever you have been given covariance, go with this formula. Okay,
Okay.
and we will see how to calculate this part. Okay, don't worry. So there are some properties related to covariance case. First one is, if you will calculate covariance between x comma y, x comma x, it will give you the variance of x, right? We have seen. Similarly, covariance of y comma y, it will give you variance of y, right? Another thing, if I want to calculate covariance of x comma y, this is same as covariance of y comma x. Third thing, tell me what will be the covariance of x comma a y plus b z, your 3 random variable. Then how you can proceed?
A into covariance of x.
Okay, let's
comma
do like
y.
this. Can I write covariance of x comma ay plus covariance of x comma bz?
Yes, sir.
Similarly, I can write a times of covariance of x comma y plus b times of covariance of x comma z. So what is the meaning of these two property? If you have been given these two and you have been asked this part, you can apply this way. Okay, then you can proceed. So do you want me calculate how to calculate this covariance part?
That's fine.
Yes, no?
Sir, this will be also same to like ax plus no, okay, fine.
Not ax, right? It's not like that. Okay, yeah, suppose let me take one example, then you will get idea how to calculate expectation of x into y. Sometimes people have doubt. Suppose this is x, this is y, and let's say this is 0 1 2, and let's say this is 0 1. Okay, and suppose this is 0 by 9, this is 1 by 9, this is suppose 2 by 9, 1 by 9, 2 by 9. I think it's total is 1, right? 3 2 5 6 3 9. Yes, total is 1. So this will be fy of y, marginal of y, right? And this is fx of x. Yes or no? So what this is 3 by 9, this is 6 by 9, and this is what is marginal of x 0, fx 0, 1 by 9, 3 by 9, 5 by 9. Okay, everyone is getting this part, right?
Yes, sir.
Okay, so question is, suppose question is what will be the covariance between x comma y? Then what is the formula? Expectation of x into y minus expectation of x into expectation of y, right? So first let's try to see okay, what will try to see what is the okay, how will you calculate the expectation of x? How will you calculate the expectation of x? This is summation of x into fx of x, right? This means what? If you see what is the values associated with each values of x, so what if you have to do 0 into 1 by 9?
Yes, sir.
Yes or no? So this is the marginal PMF for x, right? So 0 into 1 by 9 plus 1 into
3 by 9.
3 by 9, because here we are talking about only about x, right? It will be 2 into 5 by 9. So it will be whatever the answer, okay? Then what about the expectation of y? So expectation of y will be 0 into 3 by 9
3 by 9.
plus 1 into 6
6
by
by
9,
9.
right? So 6 by 9 will be the answer. The main thing, how will you calculate this expectation of x into y? So expectation of x into y is nothing but you have to calculate summation of x into y, whatever is there. And since this is the then you have to calculate the joint probability. Means how will you proceed? So it will be 0 into 0 and
into 0 by
0
9.
by 9. Everyone is getting this
Yes,
value,
sir.
this
Yes.
value, and this value. So it will be 0 into 0 into 0 by 9 plus 0 into 1. And what is the joint probability for these two value? 1 by 9.
1 by 9.
So 0 into 1 into 1 by 9. Then 0 into
0
2
into 2
into 2 by
into
9.
2 by 9.
Correct? Then next 1 into
1 into
0 into
0
1 by
into
9.
1 by 9.
Then 1 into 0 into 1 by 9. Similarly, 1
1
into
into
1
1
into
into
2 by 9.
2, 2 by 9.
Then plus 1
1
into 2
into 2
into 3 by 9.
into 3 by 9.
So whatever the values you will get, so values you will get, this will be 0, 0, 0, 0. So it's 2 by 9 and 6 by 9, that is 8 by 9. So your answer will be, and what is the expectation of x? 5 to 10, 13 by 9, right? So what you have to do, it will be covariance between x comma y will be 8 by 9 minus expectation of x 13 by 9 into 6 by 9. Okay. So whatever the final answer will be there, that will be your covariance between x comma y. So you got the idea how will you calculate?
Yes, sir.
Okay.
Yes,
So there
sir.
was similar question. I can't recall the term, which term this has been asked. So question was, you have to calculate the value of alpha such that covariance was 0. Okay. If this is the case, how will you proceed? Covariance between x comma y 0. That means what? Expectation of x into y should be equal to expectation of x into expectation of y. Yes or no? So you
Yes.
have to calculate this part, this part, this part, and then equate, and whatever the value of alpha will be, it's a 6. Okay, we will see once we will finish the concept. So you can see the
Sir,
question is related to the concepts only, whatever the concept we have.
sir,
Yes.
sir, you said that whenever covariance of xy is 0,
Hmm.
that doesn't mean the variables are independent. Then how come we have used that formula of independence in this previous part?
Which part?
So just now, I think we have written.
This part.
Yes, sir. Because it's given that covariance is 0. It's not
If
given that they are independent.
very basic mathematics. If I'm saying covariance is x comma y 0, okay, what is the formula of covariance? Expectation of x into y minus expectation of x into expectation of y. Now, can I say this is equal to this part? All right.
Sir, but we can't even say that they are independent, but still we are able to use this.
We can say x and y are not linearly related. Okay.
Yes.
We can say x and y are not linear. See, you can't say x and y are independent always, right? It might be independent.
Yes, sir.
There might be some other relationship. Okay. You can simply say x and y are not linearly related. All right. So you can use the very this basic calculation. Right?
Okay, formula can be used.
Correct. So next part is
Sorry, sir. Can you please go to your table above, the tabulation you did above?
This one?
No, earlier one, the one you wrote. Yeah,
Okay.
this example.
Yeah.
Just go up.
Uh-huh.
Okay. Sorry. Okay. I was just looking at the marginal values to see whether they are the same. In which case, we know it is independent, but it's not the case here. Sorry about that.
Yeah, it's not independent. Yeah.
Sir, please can you show the solution?
This part?
Yeah, this one. Wait.
Anyway, do not worry about the solution. We will share. Okay.
Okay. Thank you.
Yeah.
So will you share the questions PDF?
Yeah, I will share. If we have time, we will solve also, and we will share with. Okay. So next part is called correlation. Okay. So okay, why correlation came into the picture? Anyone, any idea? Do not worry about whether it's correct or wrong.
One thing is about the units, and other thing is that the value magnitude is not in a close range, like something 0 to 1, something where we can say by just seeing the value it is strongly related or not?
Yeah. So basically, suppose for some data, okay, for some covariance between, for some data covariance between x and y is, let's say, 152, okay, and let's say covariance between x and y you got some 500, covariance between x and y you got for some data, let's say -50, right? Covariance between x and y you got, let's say, -100, something like that, okay? So can you comment anything which one is the strong positive or a strong negative or anything?
No, but we can just say that it
This is
is
correct.
positive and negative.
Correct. Only these two you can say, right? Not beyond. Yeah, give me 1 minute. Yeah, sorry. Yeah, so we can only comment on whether it's a positive linear relationship or negative relationship, right? Not beyond that. We can't say this is the strong positive or strong negative, right? Because we don't have any boundary for that. Yes or no?
Yes,
Correct.
exactly that one.
So that's what this correlation came into the picture, because correlation is defined as the correlation between x and y is defined as, this is rho between x comma y is nothing but covariance between x comma y divided by standard deviation of your random variable x into standard deviation of random variable y. Also, this correlation is nothing, it's a unitless measure. Okay. So because why unitless measure? Suppose x is age of persons, right? Y is, let's say, weight of person, something. So what will be the unit for this numerator part? Year into kilogram, and denominator again will be year into kilogram. You can say it's a unitless measure, right? So and there is limit for this correlation, which is -1 to 1. Okay, so if you have calculated the correlation between x and y, let's say, and this is coming out to be x and y as, let's say, 0.9, for example. Okay, then you can say, there is a strong strong positive linear relationship between x and y. Yes or no? Would you agree with me?
Yes, sir.
Okay, so that's the importance of correlation. So actually, if you are able to calculate the covariance and standard deviation and standard deviation of y, just you can simply divide these two. Actually, one smart approach to solve the questions of correlation between x and y, I mean, that is one. Sometimes what people doing, they started with standard deviation of x, standard deviation of y. No, start with the calculation of covariance. Why? One thing, suppose you have been given the options, right? Let's say you have calculated the covariance. Then if suppose covariance is coming in positive, right? See, denominator will always be positive. If suppose option A and option B, and there are 4 options, option C and D. Suppose option C and D, values for option C and D is given in negative, but your covariance is coming out to be in positive. That means C and D is anyway, it's not correct, right? You have to choose in A and B. That's the one way. Another way is, sometimes covariance between x and y is, suppose you have calculated, you will get as a 0. Then no need to calculate standard deviation of x and standard deviation of y. Are you getting my point?
Yes,
Okay.
sir.
So it's good always to start with the covariance between x and y. All right. Okay. So there are some important inequalities. Do not worry about the inequalities. Also, inequalities will be given to you. The only thing you have to do, you should know how to apply. Okay. So first one is Markov's inequality.
Sir, I wanted to ask whether the formulas will be given now.
Yes, everything. Every formula means all kind of random variables, their PMF, PDF, expectation value, CDF, variance, along with these two inequality, means Markov and Chebyshev inequality. What you have to do, you should know which means when to apply. Yes, correct.
Thank you, sir.
Yeah. So Markov inequality is nothing but, I'm not going to do the derivation part because we don't have that much time. I will just quickly go through the inequality and how to solve the problem. Okay, I hope that is fine for all of you. I'm saying suppose x is a discrete random variable. Okay, suppose x is the discrete random variable. Condition is taking non-negative values. Okay, this random value is taking non-negative values, and suppose I'm saying expectation of my random variable x is mu. This is the condition. Okay, probability that x is greater or equal to c is less or equal to mu by c. Okay, that means probability x is greater or equal to c. This is less or equal to what is mu? Expectation of x divided by c. Okay, so from where this formula came and what is the derivation behind this, we can do it later. Let's try to understand the idea behind this. Okay, anyone any thought why Markov inequality came into the picture, or Chebyshev inequality? First of all, what kind of this is? This is upper bound, right?
Yes, sir.
Because this probability can't exceed this value. Okay, so why Markov inequality came into the picture? Any idea?
Something related to CDF, sir? I don't know.
Forget about CDF.
No, to simplify the whole thing. I mean, so it's not always easy to calculate every time, and if we want to get an approximate view, we can use this.
Okay, any other thought? Okay, one comment from my side. Suppose I'm able to calculate the exact probability, then what's the point of calculating the bound?
No, I think
How
it's
much,
the it's a
like
question
how
of
much
time. How much
close?
time you need to spend to calculate that, sir?
Okay.
It's
Like
not
how?
always you need to know the exact precision.
Okay, let me give you one idea. Maybe that will. Suppose I'm saying x follows binomial 5 comma half. Okay. My question is, what is the probability that x is greater or equal to 4? Then you can calculate by using this formula, probability of x equal to 4, then probability of x equal to 5, right? And then you can apply 5c4 half raised power 5 plus 5c5 half raised power 5. Yes or no? Whatever the exact value will be there. Correct? Yes,
Yes,
no?
sir.
And by using the Markov inequality, I can solve this also. This will be less than or equal to expectation of x divided by 4. And what is the expectation of here? It will be 5 into 1 by 2. Yes or no? So that is the expectation of x here, right? In case of binomial, right? N into p. Are you getting my point? So this will be 2.5. So this will be 2.5 divided by 4. Yes, no. Are you getting this part?
Yes, sir.
So
Yes, sir.
by using this is Markov inequality. Okay. So first thing, you will get one bound, means probability x greater or equal to 4 will not exceed this 2.5 divided by 4. Another way is, another way to think what's the role of this Markov inequality. So see, in this case, I had information about my random variable, right? This x follows binomial 5 comma 1 by 2. Then I'm able to calculate the exact probability, right? Exact probability means exact answer for this part rather than calculating bound. So in which scenario this Markov inequality and all is useful? Suppose I'm saying, I had one question actually. Let me take, this question. First of all, if you see this question, suppose that a random variable x denotes the number of items produced in a factory during a week is mean 50 and variance 25. So question is, find the probability that this week's production will exceed 74. Tell me whether do you have any information about a random variable? No, right?
No.
It doesn't give you any information what kind of distribution this follows, right? Then in this case, you can't calculate the exact probability. Okay. So if we are not able to calculate the exact probability, so this Markov inequality and Chebyshev inequality are helpful at least to get a bound for that. Are you getting my point?
Yes, sir.
Yes, sir.
Okay. So, okay, what will be the correct answer here? A?
C. No. B.
B.
D, sir, D.
D. Okay.
C.
C. Yes, C is the correct. Why? What is the Markov inequality? Probability that x greater or equal to any constant C. This is less or equal to expectation of x divided by that constant, right? So this is the discrete random variable. So make sure equality sign will matter. So here question is, this week production will exceed 74, right? This means this is greater than 74. If you want to apply Markov inequality, I will say probability x greater or equal to 75. Yes or no?
Yes, sir.
Then this is less or equal to, what is the expectation of x? 50.
50.
Divide by 75. This will be less or equal to 2 by 3. So C is the correct answer. You will get the 2 marks. Understood?
Yes, sir.
Yes, sir.
Okay. Make sure, okay, so be focused with this kind of statement, okay? So
Sir,
this part is clear, right?
What is the upper bound? Upper bound?
Yeah, this is the upper bound, right?
Sir, what is actually C?
So upper bound is, means it will not exceed this quantity, right? This probability. I mean, this probability will not exceed this quantity. That is upper bound. Clear?
And there is one lower bound also, sir.
Yeah, so you have to change this inequality. Okay, you can do, basically you can do like this. Okay, suppose my question is probability. Okay, in this case, suppose I'm asking okay, question was probability x greater or equal to 75, right? Suppose my question is probability that x less or equal to 74. Then how you can proceed to apply the Markov inequality? What you can do? 1 minus probability x greater than 74. Yes or no? Can I do this?
Yes.
And
Yes.
if
Yes,
this
sir.
is the case, can I do 1 minus probability x greater or equal to 75? And at this part, I can apply the Markov inequality or not?
Yes, sir.
Got it? Okay.
So what is the, where do we apply the concept of lower bound? Upper bound I understood. How do we
Yeah, in this case, of
understand
lower bound you have to apply, right? In this case, okay, this place,
inequality
okay,
will
okay, one second. What do you mean by I'm saying x is less or equal to a? This is upper bound, right? This will not exceed any,
Yeah, I mean, it
this
can,
x can't exceed a, right? Similarly, this probability can't exceed this
yeah,
part. Okay, in case of lower bound, it will be something like this. Okay, x is less than, let's say, something part greater than or equal to 1 minus this part. Okay, if you will solve this, what you will get? 1 minus 2 by 3. Yes or no?
1 by 3.
So it will be greater
Yes,
or
sir.
equal to 1 by 3. Understood?
Okay.
Okay. Yeah. So everyone got this idea, right? You can see how Markov inequality is useful, right? Yes, no?
Yes.
Yes, sir.
Yes. Small question.
Yeah.
So is this only applicable to discrete random variables or continuous random variable also?
Continuous random variable is also applicable, right? So as of now, we are dealing with discrete. So that's why we are just discussing the questions related to this. Okay.
Markov inequality.
Okay, we will see about, see this Chebyshev inequality and all. No, you can extend for continuous random variable also. That's not a problem. Okay. Okay, so what is the Chebyshev inequality? Anyone, those who have done the content?
P of minus
Deviation.
sigma should be greater than equals to x minus mu under mod greater than less than equals to k sigma, and that will be greater than equals to 1 minus 1 upon k square.
Okay. Anybody else?
Yeah, probability of mod that x minus mu greater than we can sigma, that is less than variance upon sigma square.
Okay.
Sir, is there any way to remember all these things without having to mug them up? I mean, I really cannot do that. And also, one other question, sir, probably you may have skipped or not sure. You didn't talk about the expected value, variance, standard deviation for different distributions that was in the lectures. For example, NP.
Okay, those all things I think anyone can calculate, right? Also, all those formula will be given to you.
Okay.
Okay, like what is the expectation of binomial, what is the expectation of, anyway, if you want to calculate expectation of binomial random variable, you have to apply the same concept, summation of x into respective probability. Okay, so I just solved for in general, right? Whether it's binomial, geometric, Poisson, you can calculate. So if I will do every all derivation and all, I think then
No. I understand that. All
okay.
I'm asking is, will it be given in the exam, or should we
Yes,
be able to
yes.
arrive at them?
No, everything will be given to you in exam. Just wait till the end of the session. I will show you the what kind of formulas it will be given to you. Okay.
Okay. Thank you.
Yeah. The I mean the basic idea. Just let's try to understand the concept. I think it's already 7:15. We have to cover the week 4 as well. Okay. So Chebyshev inequality is also about. I mean, as of now, we will discuss for discrete only. When we will move in week 7 and week 8, there is something you will study about weak law of large number. In that case, Chebyshev inequality is very helpful. So this kind of inequality is also true for continuous and discrete both cases. But as of now, we are discussing about discrete. Okay. So Chebyshev inequality we can reach by the Markov also. So what is the Markov inequality? X greater than equal to C less or equal to expectation of X divided by C, right? And what is the condition for X? X is non-negative and
Yeah.
C should be greater than 0. Yes or no? One more thing you can
Yes, sir.
Yes.
Okay. Suppose X is the discrete random variable and expectation of X is mu and variance of X is suppose sigma square. Okay. For example. Then Chebyshev inequality says, okay, okay, you will tell me probability that modulus of X minus mu greater or equal to K sigma less or equal to 1 by K square. Okay. I'm not going to do the derivation. One idea I can give you, okay. Suppose this is the case. Then X is non-negative value. Then can I do X minus mu whole square less than C minus mu whole square? Something like this.
Yes.
Okay. Then if you'll replace C minus mu with K sigma and all, you will get the answer. Okay. So, I mean, you will get this final form. If you are interested, we can do the derivation, how this Chebyshev inequality came. I mean, this final form. Okay. As of now, let's try to, I'm hoping that is fine for all of you. Is that all right?
Yes.
Yeah, we trust you, sir. Thank you.
Okay. Yeah. So the key thing you can observe, why I'm doing like this. So you can do X minus mu square. So if I'm doing X minus mu whole square, that means it's again non-negative, right? So based on this Chebyshev inequality, you can proceed. So why Chebyshev inequality came into the picture? See, if you see in this case, here we are talking about only expectation now, right? Till expectation in Markov inequality. What if variance is also given to you? Okay. So the first form is for upper bound. Okay, this is upper bound.
Yes, sir.
Okay, and second form is for Chebyshev inequality. Probability that X minus mu less than K sigma will be greater or equal to 1 minus 1 by K sigma square. Okay. Again, do not worry about this, form if you are not able to recall. The only thing you should know how to proceed. Okay. Formula will be given to you. Okay. So either one form, whether this form or this form. Okay. So let me tell you in which scenario you can proceed. So if you see the first form, right? Probability that modulus of X minus mu greater or equal to K sigma, which is less or equal to 1 by K square. When in which scenario you can calculate. So sometimes in the question it is clearly mentioned whether you have to calculate the upper bound or lower bound. But anyway, let's see. If this is the case, can I write this part as X minus mu greater or equal to K sigma or X minus mu less or equal to minus K sigma? Would you agree with me?
Yes, sir.
I have just expanded this part. Yes, no?
Yes, sir.
If this is the part, can I write x is greater or equal to mu plus k sigma, or x is less or equal to mu minus k sigma?
Yes, sir.
Are you getting my point?
Yes, sir.
So far it is okay? Yes, no? So whenever you have been asked what is find the upper bound when probability x is greater or equal to some part, or x is less or equal to some part, you can use this first formula. Are you getting? Means suppose I'm saying x is greater or equal to some value 130 and x is less or equal to some value 70, then find the upper bound for that probability part using the Chebyshev inequality. Then you can calculate. Yes or no? Basically, you can simply equate mu plus k sigma equal to that value and mu minus k sigma equal to that value, and you can proceed. Are you getting? Yes, no? Yeah, I will take the example. First of all, this expansion part is clear, which I have. Yeah?
Yes, sir. Yes.
Okay. Let me expand the second part also. Then I will take one example. Okay. So second part is mod of x minus mu less than k sigma, right? Greater or equal to 1 minus 1 by k square. So if this is the case, can I write minus k sigma less than x minus mu less than k sigma? Yes, no?
Yes, sir.
Right, see, if I'm writing mod of x less than 2, that means what? Minus 2 less than x less than 2. Yes or no?
Yes, sir.
Yes.
So from here, can I write mu minus k sigma less than x less than mu plus k sigma greater or equal to 1 minus 1 by k square?
Yes, sir.
So whenever you have been given, find the upper bound for the probability that x is lying between some two value, you can proceed with this. Here x is lying between two value, right? Here x is greater than or equal to one value and x is lesser than equal to one value. Are you getting?
Yes, sir.
Yes, sir.
Okay. Let me take one example. I think that is there. Maybe that should be there. Okay. What about this? Yeah. Let's do like this question. Using the Chebyshev inequality, find the lower bound on the probability that this week's production will be between 40 and 60. That means what? Probability x is lies between 40 and 60, right? This will be greater or equal to some value. Yes or no?
Yes, sir.
Are you getting? So let's do that question. So question is, x is given to us, expectation of x is 50, variance of x is 25. So question is, you have to find the lower bound that x is lies between 40 and 60. Yes or no? So what you have to
Yes,
do?
sir.
That means you have to use this form, correct?
Correct, sir.
Yes,
Right?
sir.
So what is, okay, that means what? This means, can I say mu minus k sigma is equal to 40? Or you can go with mu plus k sigma equal to 60, anything. Key thing, we have to find the value of k. All right. So from here, what is the value of mu?
50.
50, sir.
Minus k, what is the value of sigma? Variance is 25, so sigma will be 5
5.
equal to 40. So this will be minus 5k, sorry, 50 minus 5k equal to 40. Can I say here 5k equal to 10? So k is
Yes.
what? 2.
2.
Yes.
Or else you can calculate with this part also. So what is the mean? 50 plus 5k equal to 60. Again 5k equal to 10, k is equal to 2. So you can equate any one. And what is the, if k is 2, that means what? This will be 1 minus 1 by 4. That is 3 by
3
4.
by 4.
That means 0.75.
Yes, sir.
Yes or no? So 0.75 is the answer. Understood?
Yes, sir.
Yes.
Clear?
Sir,
So,
in this case, sorry, in this case,
Mhm.
the formula is not given, sir.
Formula, yeah, this is the formula, right?
In the question that you were just referring to.
Okay, so in the question, it will not be given the formula. Formulas, it will be different.
Formula will be in the first question.
First slide
I
after.
think you should wait. I told you please wait for some time, but okay. Anyway,
Okay. Sorry. Please go ahead. Sorry.
one second. Let me show you out now because there are lots of doubts. I don't think I want to disturb in between.
Sorry about that. Please go ahead, sir.
No worries, no worries. Let me show you. It will take 2 minutes. Can you see my screen now?
No, sir. Yeah.
So this is the formula sheet for your quiz 1. Okay. So you can see all the random variable PMF, CDF expectation, variance and all. You can see Bernoulli, NP and all, everything, geometric Poisson and all. Okay. For a continuous, and there will be Markov inequality, Chebyshev inequality. So one form is given to you, another form you can derive, right? Means
Yes.
another form will be less than k sigma and greater or equal to 1 minus 1 by k sigma. See, now you rest is your task, right? If this is the case, you can do like this: x is greater or equal to mu plus k sigma, or x is less or equal to mu minus k sigma. Okay, understood? Okay, this is the formula set which will be given for your quiz 1 exam. All
So
right.
what's the use of this beta and gamma function? Beta and gamma.
See, if there is anything extra, do not worry about that. Okay. So we have been given the whatever the continuous random variable has been used in stats 2 course. Okay. If something is provided in the formula set, that doesn't means you have to use everything. Okay. Any doubt? Should we proceed with the revision part?
Yes,
Yes,
please.
sir.
Thank you.
Okay. Thank you. So now you got the idea, right? You have to equate with this part. Yes or no?
Yes, sir.
Another way, when to use this part, right? So if suppose rather than this case, x is like between 60 and 40, suppose my question is, what is the probability that x is greater or equal to, let's say, 70, or x is greater or less or equal to 40, right? In this case, what you have to do? You have to simply equate mu plus, this part. Mu plus k sigma will be your 70 and mu minus k sigma will be your 40. Fine?
Fine, sir.
Any doubt? No? You got the idea, right? In which scenario, which form of the Chebyshev inequality you have to use? Yes? No? Or do you want to do like to use this form? Okay, let's do one example, then we will proceed. Suppose let me take some different example. Okay, suppose I'm saying, so that you can get idea. X follows binomial distribution 200 comma half, for example. So my question is, what is the probability that find the upper bound x is greater or equal to 130 or x is less or equal to 70? Okay, this is something I can reframe as x is at least 130 or x is at most 70. So meaning is the same, right? Are you getting my point?
Yes.
Okay, so this will be less or equal to 1 by k square. We have to find the value of k. Okay. So first of all, which form we have to use? We have seen modulus of x minus mu greater or equal to k sigma was less or equal to 1 by k square, right? And if you will solve this, what we got? X is greater or equal to, sorry, mu plus k sigma, or x is less or equal to mu minus k sigma. So far so good?
Yes, sir.
Yes or no? So what we can do, anything, we can equate this part with this. Okay, so we can say mu plus k sigma is equal to 130. Now next part is we have to calculate what is the mu, what is the sigma here. Since this is the binomial, what is the expectation of x in case of binomial? N into p.
NP.
So 2 into 1, 200 divided by 2, which is 100. What is variance?
NP into 1.
N into p into 1 minus p, which is half again. So it will be 50. Right? So what will be value here? Value of mu is 100 plus k square root of 50, because sigma is square root of variance, right? Yes, no? Are you getting my point?
Yes.
So from here it will be k root 50 equal to 130 minus 100. Now from here it will be k square root of 50 equal to 30, and k will be 30 divided by square root of 50. So this is the value of k. You can simply substitute this value here. So you will get 1 upon square of k square, I mean 30. So it will be 50 divided by 900, right?
Yes.
Okay. You got the idea, right? If this is the or case, right? Use the upper bound. If this is the between, you can use the lower bound. Basically, one is smart approach is just solve this part. Okay. If you just solve this inequality part inside the this probability. So if you will solve, then I can write x minus mu greater or equal to k sigma, or x minus mu less or equal to minus k sigma, right? And I can write probability x greater than equal to mu plus k sigma, or x is less or equal to mu minus k sigma. This is about upper bound. If this is the lower bound, then I have to use the reverse order. Means probability that modulus of x minus mu less than k sigma will be greater or equal to 1 minus 1 by k square. Yes or no? And if this is the case, you can say probability of minus k sigma less than x minus mu less than k sigma. And if you solve this, you'll get mu minus k sigma, x is lies between mu minus k sigma less than mu plus k sigma. Any doubt here? Yes? No? No?
Yes, sir.
All right. So then let's proceed for week 4. I think in week 4 we have discussed in detail in the open session. But anyway,
Can you give the example for the second condition? Whoa, question. Example of question. How will be the question?
Yeah, x is lies between these two, right?
No, sir. For the second one. Uh, yes. No, sir. 70. Yes, yes, sir. Yes, this type. How will be the question?
Yeah, question will be something like that. What is the probability that x is greater or equal to 130, or x is less or equal to 70? Okay, or it will be like this. You can, if you you will talk about a statement, so it will be find the upper bound for the probability that your random variable is at least 130, or your random variable is at most 70. Okay, so this is the meaning of at most, and this is the meaning of at least. All right. Okay. Yeah.
Sir, in the case of upper bound, what will be the statement there?
It might be very right. I can directly give you this one. Okay, or else I can ask what, find the probability that, okay, if I will ask find an upper bound by using the Chebyshev inequality, that probability that your random variable x will be at least 130 or at most 70. This means what? Probability what? X will be at least 130 or x will be at most 70. Got it? Then it will be 1 upon 1 by k square. Clear?
Yes, sir.
Yes, sir.
So,
Sir?
yes?
Could you please explain the previous question again? The one before this.
This part?
No, the one before this.
This part?
Yes, sir.
What is your doubt?
Like, could you explain how you'll equate 40 and 60 in terms of expectation and variance once again?
Okay, if you didn't get at the same time, you can ask at the same time, right? No worries. So this is the part, right? Yes or no? This is the form when your x will be lying between two value, right?
Yes, sir.
Yes or no?
Yes, sir.
Correct. So if this is okay, this part is same as this form. I mean, both form is same.
Okay, so my doubt was that if x lies between two values, then it will be 1 minus 1 by k square, and if it doesn't lie between two values, then only 1 by k square, right?
Correct, correct.
Okay.
So not memorize like this. Okay, it always good to expand this form.
Yes, sir.
Okay.
Yes, sir.
Clear?
Yes.
Okay, so in week 4, actually major concept is nothing but if I have a x as a discrete random variable, okay, let's say x is taking value x1, x2 up
Sir,
to xn. Yes.
sorry to interrupt, but can what will happen when it will ask lower bound instead of upper bound in the question?
What is this part?
No, sir. The example you gave about the question.
See this part.
Yes, sir. For
See,
lower
if
bound.
1 second, if you will if this will ask about lower bound, right,
Yes,
then
sir.
your x will be lying between two values. Only then that inequality will be satisfied. Okay, so you can see. Okay, just try to think a bit, right? Well, if you will focus a bit about this form which I'm highlighting here, you will get the lower bound only when your x is lying between these two values. Okay.
Okay, sir. Okay, sir. Got it.
Got it? Yeah.
Yes, sir.
So just try to
Sir, could you show the conversion of that form, like from the formula to get this lower
see,
bound form?
if you are taking the screenshot right now, then you, wait for some time. After this session, we will upload on the portal. Okay. This is fine. That's what you want.
Sir, you wrote the conversion into this form in a different page, right?
Both are the same actually.
Sir, I think she's asking about the expansion of the
Yeah,
inequality.
that's what that same thing I have done, right? If you want this, okay, anything. I don't know what is the thing you want here. That's the same thing you want.
Yes, sir. Yes, sir. Done.
Done. Okay, you are taking this screenshot, right?
Yes, sir.
Okay. Anyway, we will upload the PDF on the portal. Okay. Let's continue the session. Okay. I think discussing the concept is more important. Okay. So in week 4, the major concept is about PDF and all. So I'm not going into the depth part, which we have already discussed in open session. But yeah, I will give you the flavor of the questions, how to solve and all. So suppose x is discrete random variable with this PMF. You know what is the property of being a valid PMF? All the probabilities should be greater or equal to 0. Addition of all the probabilities should be equal to 1. So what is the CDF? How will you calculate the CDF? CDF is nothing but cumulative distribution function, right? So how will you calculate the CDF? So CDF notation is capital F x small x. So this is random variable. This small x is one of the value your random variable is taking. Okay. So this is defined as nothing but probability x less or equal to small x. Means if I will ask fx of let's say a, then you have to add all the probabilities till a. Yes or no?
Yes.
Correct. Now, if you see, okay, there are some properties related to CDF. What are those? First one, fx of x is
non-decreasing.
Is a non-decreasing function, right? This is a function, okay? And second property is, if you can say, I mean, that means if x1 is less than x2, two values, right? Then f of x1 is less than f of x2. Okay, what is the meaning? If I'm saying suppose 2 is less than 4, for example, then f of 2 will always be less than f of 4. Also, one more thing, if this is the discrete random variable, so this will be the step function, right?
Yes, sir. Sir, there would be equal to, right? Less than equal
Yeah,
to.
you can do it. You can. That's not a problem. Anything. Okay. So it is true. So key thing is, if you have discrete random variable, right? So suppose I'm saying x is follows, let's say, uniform, discrete uniform 1, 2, 3, 4, let's say 5. Okay. Then what will the probability for each xi? 1 by 5, right? So if you want to plot the CDF plot, what will be the CDF plot?
We will get a step function.
Before 1, it will be 0, right? From 1 to 2. Okay. From 1 to 2, it will be
1 by 5.
1 by 5. From 2 to 3,
2 by 5.
from 3 to 4,
3 by 5.
3 by
and
5.
from 4 to 5,
4 by
4
5.
by 5.
and from 5 onwards, it's 1.
1.
Okay. Those who are worrying how to calculate this, so actually you can calculate this. So f of 1 is what? Probability that x is less or equal to 1, which is nothing but probability of x equal to 1. What will be f of 2? This means probability x is less or equal to 2. That means probability x equal to 1 plus probability of x equal to 2, which is 1 by 5 plus 1 by 5, which is nothing but 2 by 5. All right? Yes. Okay. And this is the step function. If your CDF plot is like this, then this you can see this kind of jump, right? So this jump is nothing but the probability at a single point. What I mean by that, suppose I'm saying what is the probability x equal to 2, this will, so this jump will give you the probability at x equal to 2, and this jump will give you the probability at x equal to 3. So what is the probability x equal to 2? So 2 by 5 minus 1 by 5, which is again 1 by 5. So you
1
can
by
see
5.
probability at x equal to 2 is 1 by 5. What is probability x equal to 3? 3 by 5 minus 2 by 5, which is again 1 by 5. All right? Yes, no?
Yes.
Yes, sir.
So this is the CDF graph for discrete random variable. One important properties we have seen, okay, we can actually, you can keep in mind for this only, rest you can calculate. What is the probability that, here consider your x is a discrete random variable, okay? I haven't entered for continuous. So if this is the case, tell me, suppose this is A, suppose this is B, 1, 0, and suppose x is somewhat here, okay? So if you want to calculate x is more than A but less or equal to B, how you will find? Okay, so basically, if, can you see, if I will subtract this from this blue part, okay, till A, this green part, okay, I can find the probability A less than x less or equal to B. Would you agree with me?
Yes. Yes.
Right. So what is the blue part?
Probability less than B. X is less than or equal to
X
B.
is less or equal to B, minus what is the green part? X is less or equal to
X is less than equal to A.
right? What is this part? Can I write these two as fx of B minus fx of A? Yes or no?
Yes.
Yes.
So this formula is very important, right? So if you, why? Because if you know the CDF of your random variable, right, then you can directly calculate this like this. Okay, this is also very helpful in case of continuous random variable. We will see why. Yes, someone has raised hand.
Sir, can you go back before the example?
Where?
before the example where you were writing properly. Yes. That's fine.
Now, other values you can calculate with the help of this too. Okay, what I mean by other means, suppose I ask what is the probability A less than X less than B. So you have probability A less than X less or equal to B. See, this is the discrete. That's why it's so important. So what I have to do now?
B minus.
Minus probability that X equal to B. Only then I will get this part, right? You can see if I will
B
subtract
minus
the
1.
equal to part, I will get this part, right? What if I will ask probability that A less or equal to X less than B? So you have this info, right? Probability A less than X less than B. I can add probability X equal to A. I will get this part. Yes or no?
Yes, sir.
If I will ask probability A less than or equal to X less than or equal to B, then you have information A less than X less than or equal to B. If I will add probability X equal to A, I will get the answer. Are you getting?
Yes, sir.
Now, when it is helpful, let me show you. Suppose I'm saying I have been given X follows, let's say uniform 0 up to let's say 50, for example. Okay. My question, what is the probability 3 less than X less than or equal to 5? So you can do in both way. One way is probability that X less or equal to 5 minus probability that X less or equal to 3 by formula I can do.
Yes, yes, sir.
And what is the value of probability X less or equal to 5 if you will add for here?
1 by 10.
Sorry, just think a bit.
1 by 10.
Why 1 by 10?
Why? 1 by 51.
Why 1 by 51? Is the X less or equal to 5?
5 by 50.
6 by 51.
6 by 51 because it's starting from 0, right? You have to add, see here, probability X equal to 0 up to so on, if probability X equal to 50 will be 1 by 51, right? So here you have to add 1 to 5. All right. Are you getting? So it will be 6 by 51 minus 4 by 51, which is nothing but 2 by 51. Yes or no? This is by formula. Or what you can do, in this case, what we have to do? This means what? Can I say probability? Okay, you will tell me what is the meaning of X is greater than 3 and less or equal to 5. That means what? X is either 4 or 5. Can I say or not? This is the meaning, right?
Yes, sir.
And what is the X? What is the probability X equal to 4? 1 by 51. 1 by 50, which is again 2 by 50. You can see values are the same. Okay.
So could you explain that? Yes, sir.
Sorry.
6 by 51.
Okay, so probability X less than or equal to 5 means what? What this is? See, probability X less or equal to 5 means what? Probability X equal to 0 plus probability X equal to 1 plus up to probability X equal to 5, right?
Got it.
Right? So 1 by 51, 1 by 51 up to 6 by 51. Clear?
Yeah.
Yeah, okay. So this is all about, discrete random variable. Okay. So in continuous random variable, okay, so I'm not going in, give me a minute. Let me show you something. I mean, something is, I want to show you the PDF which we had discussed, in the last, I mean, when we did week 4 open session. Okay. So you can find the PDF which we are discussing during the sessions. And you can go on the portal. Okay, under supplementary content, you can find one section, live session notes, and you can click here. Do not worry about the rest of the PDF. We will upload remaining PDF. So you can find this week 4 open session. Okay, from here you can find the PDFs. So this week 4 open session notes, you can go with this. You will get some sort of I mean, idea in more details, okay, which we have discussed. For now, I'm just going with I'm covering the quickly. Okay. Now, what is the continuous random variable? Okay. So actually, whenever you will get the C, okay, here you can see your CDF in your CDF plot, there is step functions, right? There is a gap, there is a jump, right? But for continuous random variable, your CDF will be something where you cannot get a jump. Means your CDF will be something like this. Anything. Okay, this is the 1, this is the 0. Okay, so if I will ask, let's say this is 2. If I will ask what is the probability x equal to 2, can you find?
Yes, sir.
No.
No, you
No.
cannot.
Oh,
It will be
Probability
zero.
because it's a continuous, right? You can't find probability at a single point, right?
It's only the interval of the range.
Yes. If I will ask what is the probability that x will lie between 2 to 4, suppose this is the 4. Now you can calculate this area, right? From here to here.
Yes, sir.
Yes or no? So in continuous random variable, actually when my random variable become continuous, whenever you have large numbers, right? Large observations. What I mean by large, okay, let me open that PDF. Actually, so you can see I took lots of example in the when I discussed the week 4 open session. Okay, suppose, okay, here you can see initially you had, let's say, x follows uniform 0 to 10. Okay, then you can find the jump, right? In your CDF plot, you can find the jump. Suppose x increased 50, then this jump will be a bit less, right? If your x is till 100, again your jump will be, I mean, it will decrease. Yes or no? Similarly, your number of users will be increased, let's say 500, 5000. You'll find the continuous curve, right? That means there is no jump. If there is no jump, in case of discrete random variable, if there is a jump, you can find probability at a single point, right? But in case of continuous, you can't calculate the probability of single point. That's why probability at a single point is 0 in case of continuous random variable. Are you getting? So probability at a singleton point is 0 in case of continuous random variable. All right?
Okay.
Okay.
Yes,
So,
sir.
yeah. So properties are, this CDF plot has no jump. Okay. Another one, probability at a singleton point is 0. One property we have seen in case of discrete. What was this? We have seen it was fx of b minus fx of a, right? And we have seen this also. So probability x less or equal to b. Okay, for this part, one more thing. For this part, how I can calculate probability? I mean, basically probability a less than x less than equal to b, plus I need to add probability x equal to a, right? But probability at a single point is always 0. This will be same as probability a less than x less or equal to b, right? This will be same as fx of b minus fx of a, correct?
Yes, sir.
If I will ask probability a less than equal to x less than b only, that means what? We have this information, means probability a less than x less or equal to b. To get this part, what we have to do? We have to subtract x equal to b, plus we have to add x equal to a. Yes or no? Are you getting my point?
Yes, sir.
But probability at a singleton point will be 0. Then again, this will be fx of b minus fx of a. Are you getting? What if
Yes,
probability a?
yes.
Sorry?
You are telling it this for continuous random variable.
Yeah, this is continuous random variable because I moved on continuous. I told you, right? Okay.
Yeah.
Not this. This is not true in case of discrete. So for this part, we have information about this. If I will subtract probability x equal to b, I will get this part, right? And probability at a single point is 0. Again, I got fx of b minus fx of a. So the key thing in case of if x is continuous random variable, so irrespective of equality sign, whether I'm writing like this, whether I'm writing like this, or whether I'm writing this part, or whether I'm writing this part, all are true as a probability x less or equal to b minus probability x is less or equal to a. That means fx of b minus fx of a. So if this is the case, you can everything you can equate like this. Okay, this is very, very important. But it was not true in case of discrete random variable. All right.
Yes, sir.
Okay, so I will take the questions related to this. Do not worry. So let me give you the idea behind the PDF also. I mean, in case of discrete, we had probability mass function. In case of continuous, we will be having probability density function. Okay, so what is the probability density function? Suppose, okay, first of all, suppose this is any kind of function. Okay, this is a function of x. Okay, for example, and what is the CDF? If I want to define fx naught, this is probability x less or equal to x naught. Okay, so suppose x naught is somewhat here, so that means what? This, I'm interested in this region. Yes or no? If I
Yes,
want
sir.
to find this
Yes, sir.
probability in case of continuous, what we have to do? We have to integrate the region from minus infinity to x naught. So suppose minimum limit is x naught and here upper limit is x. Sorry, minimum is minus infinity and upper is x naught. What we have to integrate? This PDF. Okay. So this is something called probability density function. Okay. Is this all right? This is
Yes,
something we
sir.
have seen. Okay, if you want to, so you can see we have already discussed this kind of strips and all. Okay, so the key thing is in case of discrete, we are using the summation sign. But okay, in suppose x is discrete and you want to calculate fx of 2, then what you will do? Let's say you will do x equal to 1 plus probability x equal to 2, right? In case of discrete. But if x is continuous, what you have to do? You have to integrate that part. All right. Integration in this, the sign of integration is nothing but called continuous summation. Are you getting? What if I will ask this region? Suppose this is A, this is B. Then how will you calculate probability that A less than X less than B? That means what? You have to integrate A to B.
The limits will be from A to B.
Yeah, this dx. All right.
Yes.
Okay, density means what?
Mass upon volume.
Mass
Mass
upon,
upon volume.
okay. Here volume means what? Mass divided by area, right?
Yeah.
Okay. That is something we have discussed already in detail. So key thing is, okay, if you, in case of discrete PMF, valid PMF, what was the two key property? All the probabilities should be greater or equal to 0 and summation of all the probability will be 1, right?
1.
In case of PDF, what will be the probability properties? This fx of x should be greater or equal to 0, right? Second, integration over all throughout the range, let's say minus infinity to infinity, should be equal to 1. And what is the third property? Fx of x is piecewise continuous. Okay, so what do you mean by piecewise continuous? Means suppose your fx of x, you know, defined as, let's say, x cube for some range, let's say a1 to a2, and some another x cube plus 2 for a3 to, you know, some a4, something like this. So it should be continuous for this, it should be continuous for this. Okay, so this is the key thing about your you know, week 4 continuous random variable. So whenever you have been given any constant, then you can calculate this part, okay, by using the property of being valid PMF. One more thing, do you have any session at 8?
Yes, sir.
Yes,
Yes, sir.
Okay,
Math
so
session.
okay, do not worry. So anyway, we have covered the all the concept. The let me show you the property which we have seen here. Okay, like for week 4, what kind of question you can see? So suppose there was one 3 marks question, I can't recall the term. So suppose fx of x, so this capital F, F denote the CDF. CDF is given as 1 minus e raised to minus 4x. Okay, so first of all, this is the continuous CDF, yes or no?
Yes, sir.
Yes, sir.
Okay, now your question was to calculate this part. And we have seen probability A less than X less than or equal to B. This is same as fx of B minus fx of A. Yes or no?
Yes, sir.
Yes, sir.
So what will the then what I can write here? Probability X less or equal to 6 minus probability X less or equal to minus 4.
Yes,
That
sir.
means what? Fx of 6 minus fx of minus 4. Right?
Yeah.
And what is the fx of X here? 1 minus e raised to power minus 4 times
X.
X. So it will be minus 24 minus what?
0.
0, right? Because
Yes,
your
zero.
support
X is
is
always
greater or equal to
greater.
0.
Not
Okay.
negative.
So this basic thing you have to keep in your mind. So this option will be correct. See
Yes, sir.
how easy it is, right? You will get 3 marks. 3 out of 40. That means 3 into 2.5 out of 100. Right? More than 6 marks for this question. Yes.
Where we have to do integration parts.
You can do integration. That's not a problem. So your integration will be basically but before integration you need to calculate fx of X. Okay. See,
Sir,
your CDF, once again, CDF is defined as what? Minus infinity to X, fx of X, right? This is PDF and this is CDF. If you want to calculate PDF, then you have to differentiate the CDF. Okay? Understood? So, what you have to do here? Then if you want to integrate, see, if you want to integrate, then what you have to integrate minus 4 to 6 fx of X dx, right? But we don't have fx, this PDF. What you have to do, you have to differentiate this CDF, right? You have to differentiate 1 minus e raised to power minus 4x, whatever the values you will get, you have to then integrate this part. Since X is greater or equal to 0, then you have to integrate 0 to 6, whatever the PDF you will get. Understood? That's why I was emphasizing on this part, right? Properties of CDF. See, without calculating the PDF, you can solve this part. Understood?
Yes.
Okay. Now solve this question. See, again, this is very three marks question. Solve this and we can. And
Sir,
tell me
how
what,
will I identify whether it is a discrete or continuous example?
see, you can simply plot the CDF. Can you find the jump here?
No.
Right? Understood?
Yes. Okay. So it depends on the function that.
Correct.
Okay.
Now you can you tell me the value of K here? Sorry, A. So you know this kind of question you can see from the week 4 actually. Okay.
Sir, I have a doubt. What if in this piecewise function, something like it says 0 otherwise, if it was not like that, we have two separate conditions and few values on real numbers are missing, then
Missing means what?
like it says some value for positive and some values for negative. So 0 left from number line. We didn't consider it in piecewise. Is can it be can this case happen in exam?
Actually, I'm not getting your question. You mean this support is changing? Means
Yeah,
like let's say something here, some function and minus 1 to 2, some function then 3 to 5, something like that.
No. In the piecewise function, if they have written that this value for x belonging to the positive numbers, positive real numbers, and 0 otherwise. So if it is not written 0 otherwise, it will be
That means
always there.
okay. Actually, this is the good way to show the valid PDF, right? I mean explain like suppose I'm writing like this. This means I have full information. If x will be between 0 and infinity, this will be the function. Otherwise, it will be 0. I mean, fx will take value 0. If it's not mentioned clearly, then you can consider apart from those support, your function will take value 0.
Okay.
Suppose I didn't mention this like this. I gave fx is like this only. This means apart from this support, fx will be 0.
Okay, sir.
Okay. Yeah. So yeah, tell me what is the answer. You are calculating or you want to calculate? Yes, no.
Could you please calculate?
Could you explain the question only?
Okay, so question is what? This is the PDF is given to you, right? Fx equal to 1, e raised to power 1 minus ax. Question is you have to calculate the value of a such that f is the valid density function. When your f will be valid density function, it should be greater or equal to 0 and area under the curve should be equal to 1, right? So fx of x is defined as 1 e raised to power 1 minus ax, right? I think. Yes.
Yeah.
And support is 0 to infinity. You can see this is hint is given to you. If you want to integrate anything e raised power kx dx, it will be e raised power kx divided by that constant, right? This is the hint. So what I can do, first of all, this will be positive, right? Second property I can use area under the curve should be equal to 1. That is the property, right?
Yeah.
Yes,
So
sir.
what is the support? 0 to infinity.
Infinity.
So 0 to infinity e raised power 1 minus ax dx should be equal to 1.
Yes,
Correct?
sir.
Now, if you will see this clearly, so can I write e raised power 1 minus ax and divide by minus of a?
Yes.
And 0 to infinity equal to 1, right? From here onwards, what you can do, 1 by a you can take outside and minus, so you have to substitute the values here. So if you substitute infinity, what you will get? 1 minus infinity something, minus infinity,
Minus infinity.
minus
Correct.
of e raised power 1 minus
1.
0. You have to substitute at the place of x, right? So
Yes,
1
sir.
minus 0 will be, right? So it will be 1 upon a. This is the multiplication. This minus, if you take inside the bracket, what you will get? E raised power minus infinity is what? 0. It will be minus 0 plus e raised power 1. It will be 1 upon a into e equal to 1. So e equal to a. So value of a is e. Got it? So option number
Yes,
D
sir.
is the correct. Understood?
Yes, sir.
Okay.
Yeah. Similarly, you can see here you have to calculate the value of x. Hint has been given how to calculate. One more question. Yeah, let's calculate this one, and then which session is maths or Python?
Math, sir.
Maths.
Okay. This question will do, and I will upload the PDF of questions and the notes I have written. You can solve the questions. Okay.
Okay, sir.
Okay. Just let's try to do. Do you want to solve me and or okay? Let me solve it. So question is: Shruti throws a dart onto a circular board, and random variable x denote the distance from the center to the point. So you can guess the idea, right? It is continuous random variable. I'm discussing about distance, right? Also, it is given PDF of x is kx 1 minus x square, right? Kx 1 minus x square, and what is the support of x? 0 to 1. So very first question is you have to calculate the value of k. Now we know we have to use the properties of PDF, right? So what is the property of PDF? First of all, it is greater or equal to 0 or not for this support. It is greater or equal to 0. Second is area under the curve will be equal to 1. So it will be 0 to 1 because area support is 0 to 1. K times x 1 minus x square dx should be equal to 1. Would you agree with me? Yes or no? Now k I can take outside. Can I solve like this? X minus x cube.
Yes, sir.
Now k I can integrate like this: 0 to 1 x into dx minus 0 to 1 x cube dx equal to 1.
Yes, sir.
There is some background noise. Can you mute? I think you have played some another video. So what is the integration part for this? You know what is the
X
x raised
square.
power n dx is nothing but x raised power n plus 1 divided by n plus 1, right? So it will be x square by 2 minus x raised power 4 divided by 4, 0 to 1 equal to 1. First thing we have to substitute the value of upper limit. So it's 1 by 2, 1 is square by 2, minus 1 raised to power 4, which is again 1 by 4, minus if you put 0, you will get 0, right? So this is nothing but 4 minus 2, which is 2 by 8 equal to 1. So k into 1 by 4 equal to 1. So k is nothing but 4. So you can see
Yes.
4 is the correct answer, right? You will get 2 into 2.5. That means 2 into 2.5, how much? 5 marks, right? So you will get 5 marks. Now next question is you have to calculate this part. Okay. So since this is PDF is given to you, you can directly integrate, right? Probability that you have to calculate 1 by 4 less or equal to x less than or equal to 3 by 4, right? That means what? I can integrate 1 by 4 to 3 by 4. Since I have value of k as 4, it will be 4 times of x, 1 minus x square dx. That's all.
Yes.
Right?
Yes.
Are you getting my point, right? Here CDF is not given to us. If CDF is given to us, I can directly calculate this part, f of b minus f of a, right? But here it will be difficult to you. You have to calculate CDF, then apply the concept. Even though you can do, answer will be correct. But it's good to save our time. Okay. So now the same approach you have to do. It will be 4 x minus x cube dx 1 by 4 3 by 4. Yeah, same approach. 4.
So we are doing same thing again, sir.
Yeah, same thing again.
By integrating this PDF, we are finding CDF, then we are substituting the values.
No, we are not finding the CDF here. We are just calculating this part. See, probability A. Yeah, see, you can see, I told you, right? If this is the part, if I want to calculate A area under this A and X is lie between A and B, means probability A less than XB. Then what I have to do? I have to integrate from A to B by PDF, right?
I got it.
Got it? Yeah. The same thing I'm doing, right?
Yeah.
Now, okay, the same thing you can do here. It will be x square by 2 minus x raised to 4 by 4, 1 by 4, 3 by 4. Okay. So just substitute this value. Okay. First substitute 3 by 4 square by 2 minus 3 by 4, 3 by 4 is for 4 by into 4, then minus of this one. Okay. Is this all right?
Yes.
Okay.
Yes.
So you got the idea, right?
Yes, sir.
Okay. What kind of question it has been asked during from the week 3 and week 4? You can see the questions are very easy. Okay. In this question, yes.
Sir, sir, I have one problem where I'm unable to get how to proceed. Shall I post it here in this chat, and will you guide me, please?
It's from PYQ or so what? Something else?
Yeah, I was actually some.
Just a mock, I think.
I think mock, sir.
Okay, you can post or else just tag me on Discord. It will be better. I will write the solution and post there. Okay, yeah. So one more question you can see here. X follows binomial n comma p. So first part is you have to calculate the value of n for which this is true. I mean you have to equate this part. So it will be 3c. N choose 3 half raised for n equal to n choose 2 half raised for n. From here you can calculate the value of n, right? Then you have the information from here, right? If this is the binomial, whatever the value of n will be there, you can calculate the mu here, right? You can see it is lower bound. Yes or no? So this means what? What you can do? Can I write this as a mu minus 2 sigma less or equal to x less or equal to mu plus 2 sigma greater or equal to 1 minus 1 by k square, right?
Yes, sir.
Okay. Similarly, you can calculate these two parts and just substitute the values. Okay. So you can see whatever the concept we have discussed, the question depend on them more or less. Now you can see this part also. This is very simple. You can apply what is the variance of x into y. It will be expectation of x square into y square minus expectation of x into expectation of y whole square, right?
Yes.
And hint is given if x and y are independent, x square and y square are also independent. That means I can write like this. Yes or no? If I can write like this, then what is the formula of variance? Expectation of x square minus expectation of x whole square. So you have to calculate this part. This is given to us as 2. This is given to us as 10. You can calculate this part similarly for y, right? Okay, what about this part? Yeah, then we will wind up the session. What about this part? Which one is the true? Let me write the Markov inequality that will give you the idea. Probability x greater or equal to c less or equal to expectation of x divided by c. Now tell me.
That's the
Second one.
lambda by c.
Okay, how second one? Can you relate with this? I think this is second one. If you are saying it's totally wrong, right? Just
First one.
How? Do not see. There are only 4 options. If one time you are saying first one, second one, third one, fourth one, within 4 trial you will get the correct answer. But thing is that why?
Sir, D, sir. It is satisfying the condition given.
Okay. See, first of all, apply the smart approach. This is both are greater than psi, right? In Markov inequality, one is greater, second one is less than. This is not. Less than. No. If one is less than, one should be greater than, right? Greater than, no. Greater than, less than. This is true, and why I will tell you. So this probability x greater than 25, that means what? I can write this is a probability x greater or equal to 26 or not?
Yes, sir.
Yes or no? And this will be less or equal to expectation of x. In Poisson, what is the expectation?
Lambda 10.
10 by 26. That's why it's the clear?
Got it.
Now you can see that this question, you can calculate the expectation of y, right? So what you can do, you can calculate the 2x plus 1 and take the square and substitute this value. Or else what you can do, you can expand this part. It will be 4x square plus 1 plus 4x and then take expectation. Okay. Either way is correct, right? If you are either you are proceeding with this method or this method, in both situations you will get the correct answer. Okay.
Okay.
And we have seen this part, right? You have to calculate the alpha by applying this concept. All right. Okay. Was it helpful to all of you?
Yes.
Thank you very much.
Yes, sir. Yes, sir. Thank you.
So thank you to all of you, and all the very best to all of you.
Thank
Sir,
you.
Okay.
sir, please upload the questions PDF.
Yeah. Question PDF and the notes I have written, it will be uploaded by tomorrow morning. Actually, I will share with the support team. They will upload by tomorrow.
Don't
Okay,
you
but
have
by
access
tomorrow,
to the live session notes?
We don't have enough time, sir. 25, 27 exams.
yeah. So actually, yeah, I will ask them to try to upload by tonight only.
Okay, sir. Thank you, sir.
Okay, so thank you to all of you. I hope session was helpful to all of you.
Yes.
Okay. All the very best to all of
Thank
you,
you.
and we'll meet in the quiz one. I hope you will pass with the flying colors. Okay. So yeah, thanks all.
Yeah.
If you
Good
have
night, sir.
anything else, just tag me on this course. I will write the solution or something else. Okay.
Thank you.
Okay. Thanks all.
Okay.
Just
Bye.
enjoy your math session. Okay. Thank you.
Thank you, sir.
Thank you, sir.
Thank you. Bye.